Okay, so the next thing I'm going to talk about is how to use Python scripting to control objects within Rhino's environment. In particular, I'm going to talk about how to control the camera. And this is another really powerful use of scripting in Grasshopper, where you can actually get access not only to the geometry that you're building within Grasshopper, you can have access to actually everything that's contained within your Rhino environment. And you can utilize this to do things that you otherwise wouldn't be able to do in Grasshopper or in Rhino itself, such as animate cameras and create simple animations straight within the program. So the first thing we'll do is create a path for the camera to follow. So I'm just going to create a simple arc object and use the base point of my geometry as a starting point, and I'm just going to sweep an arc around, and then I'm going to create a geometry node within Grasshopper and set my curve as that geometry, so now it's referenced in. And the next thing I'm going to do is create a series of points along this curve that will denote the position of the camera at each frame in my animation. For that, I will use the divide curve node. I'm going to pass in my curve, and for the number of points, I'm going to specify the number of frames in my animation. So I'll set that to 100 as a start, and here I can rename this as number of frames. And finally, I just need a way to access one of these points at a time, which is driven by another slider, which will be the actual frame of my animation. So I'm going to create another slider to specify which frame of the animation I want. And I'm going to create a list item node to basically pull one point from this list of points at a time. If I hide that, you can see now I can reference any of these points. And we're actually going to use Python to move the camera to this point at each frame. Okay, so to start, I'm going to drag out another one of these Python nodes and get into the script. So to gain access to the camera, as well as other objects in the Rhino environment, we actually need to start using another library called script context. So I'm going to start off with importing our usual Rhino script syntax. And then we're also going to import another library called script context. And just like before, we're just going to create a shortcut for that called sc. What script context does is it creates a link between Python and the actual documents that we're working with. And one of the cool things about Python is that you can use Python to work with both the Grasshopper document here and the Rhino document, but you have to tell it which document you're actually working with. So the first thing we're going to do is access this script context library and then .doc. And this script context .doc is a basic method for telling Python which document you want it to use. And to start off with, we're going to pass it gh_doc, which is a reference to the main Grasshopper document. Okay, so right now Python will be using the Grasshopper document, and we're going to pass it in some inputs that specify the location of the camera. So we're going to create a variable called location, and then just like before, we're going to use Rhino script syntax to coerce a 3D point out of an input. So here we're going to input a location point. Okay, so we'll click OK. We have to set these inputs to take in our camera location inputs. So we'll create a location input, and then we'll pass that point into there. So now that location is in the script, and it's being and the actual point is being stored in the LOC variable. So now that we have the point, we actually have to switch to the Grasshopper document to work with the camera in this viewport. So what we're going to do is create a reference to the active viewport by creating a variable called VP, it just stands for viewport. And then we're going to use a function within script context. So again, script.doc. And now we're going to access the actual view that's active within the Rhino window. So we're going to type in views dot active view dot active viewport. This will actually create a variable which will reference the active viewport in our Rhino document, and from there we can change different properties of that viewport, including its camera. So now once we have that reference, we'll type in viewport, and then we're gonna use a function to set the camera location within that viewport. So we say vp.set camera location. And there's specific syntax for how you use this function. You can look this up in the reference online, but it requires two inputs. The first is the location, so we'll pass in our location input. And for the second input, you have to pass false. Okay, and now basically this function will take the point and set our camera to that point. So if we hit test, you can see that now our camera has changed. It's actually moved to that point in the model, and as we step through the frames, it's actually moving. It's hard to see now because we can't see any of the geometry, but down here you can see that the location of the camera is actually moving as we step through this. So to make this work, the second thing we need to do is we need to tell the camera where to look at. So not only the location of the camera, but the target. And for the target, we're just going to use this point. That is the starting point of our geometry. So we're going to create another input here called target. And we're going to pass that point into the target. And just like before, we're going to create a parameter to capture the actual point geometry. Here we'll pass in the target input. And we're going to use another function to set the camera direction. And the direction is a vector. So we can't just set it the point to look at. We actually have to tell it a vector direction. To get that vector, we simply subtract the location from the target. So if we subtract the target point from the location, we get the direction of the camera. And here we pass in true. Now if we exit out of this, you can see that as we change our input, the camera is actually moving along that line, but the point that it's looking at is staying the same. And this will update every time we change the geometry. So we can actually start to move these lines around. Maybe I'll raise this up a little bit more, and maybe I don't want this point to look at the base, so I can actually, within Grasshopper, move that point up so it's looking more at the middle of the structure. So I'll just use the move node, pass in that point. For my translation vector, I'll pass in a unit z vector, and then that point I'll put into the target. And now I can have a slider to basically set the height of my view as I rotate around the structure. So that's a very basic sort of animation setup, and now you can experiment with having different paths for the camera or other ways to instantiate the camera. You don't have to always have a follow path, as long as you have a way to generate a set of points for the camera to follow, which are triggered by a slider. This will work the same exact way.